Ladies and gentlemen, please take your seats. Our program is about to begin.
Ladies and gentlemen, our program is about to begin. Please silence your cell phones or place them on vibrate.
أيها السيدات والسادة، سيبدأ البرنامج بعد قليل، لذا نرجو منكم التكرم بالجلوس في مقاعدكم.
This year we have speakers from around the world, so let's discover what we have today.
The true thing, the true strength is knowing your capabilities, knowing your limits, and still being true to yourself is a form of resilience.
Resilience means coping with the current threats of the very complex cyberspace, coping with the uncertain.
What I was hoping to share and hope to educate the audience is that it is my point of view about resilience and examples that I have seen in my life.
It's very inspiring.
Amazing.
It was really good.
Hello, good afternoon, everybody. Welcome to WEP session today. I hope you enjoyed the cooking show in the morning and learned how we can cook more sustainably for the future. So today we have a keynote speaker, Dr. Malak AlNory, and it's my pleasure to introduce her. Dr. Malak AlNory is an expert in clean energy and clean water integration, providing innovative solutions and strategic planning in these areas. She works as an advisor of sustainability and climate change in the Saudi Ministry of Energy, representing the Kingdom of Saudi Arabia in international policy negotiations pertaining to energy and climate change. She has represented the Kingdom in various intergovernmental conventions, including the United Nations Framework Convention on Climate Change, the Intergovernmental Panel on Climate Change. She published research on innovative and sustainable integrated energy and water solutions, including grid optimization to improve water desalination projects. Prior to her work at the Ministry of Energy, she is the Provost and Dean of Graduate Studies and Research at EFAT University. Dr. AlNory won several awards for her contribution to clean energy research. The latest is Mission Innovation Champion 2020. She is also an advocate for women in clean energy. She was appointed as Clean Energy Education and Empowerment International Ambassador, representing Saudi Arabia in this initiative under the Clean Energy Ministerial. She is an editorial board member at the Nature NPJ Clean Water Journal and an advisory board member with the MIT Technology Review Arabia. It's a pleasure to introduce her and very much looking forward to her talk and questions about women in STEM. Dr. AlNory.
No, thank you. Good afternoon, everyone, and thank you very much for KAUS for inviting me for this talk. I'm very excited to be here with you, to share with you how science is leading global policy in climate change and how scientists can contribute to the solution space for this global dilemma. Wildfires, cyclones, floods, droughts, heat, rain, precipitation. What is climate change and what is not climate change? As a fact, not every change is climate change. Climate change is a persistent change in the mean and or the variability of the state of the climate over a long period of time. So in the narrower sense, climate is an average weather. And the statistical description in terms of the mean and the variability of the relevant quantities, the surface quantities, the wind, precipitation, and temperature, over a period of time that could be months, years, centuries, millions of years as well. And it can be 30 years. Why 30 years? This is that classical period that's been identified by the Water Meteorological Organization to be averaged over it, all the quantities and the variables of the surface, including the temperature and the wind and so on. So in the wider sense, climate is the state of the climate system and the statistical description of all these variables. Today, I attempt to answer with you 3 questions, which I identified. I identified them as probably the most relevant for you as scientists and scientists of the future. So what's the role of science in climate change policymaking? Does policymaking come from science, or is it isolated from science? In the real world, how scientists study climate change? What are the basic building blocks in order for us to study climate change? Is it science? How scientists contribute to the solution space of this global dilemma? Start with the first question. The United Nations Framework on Climate Change, or the Unfccc, as I will be referring to for abbreviation, it was established in 1992, and it describes climate change as the change in the climate, in the state of climate system that is attributable to human activities, which is altering the atmospheric composition, and the climate variability that is attributable to natural causes. So the Unfccc makes this distinction between the climate change attributable, or the changes attributable to human behavior and persistent anthropogenic human activities, and the natural causes. Natural causes can come from internal or external sources. External forcings, such as the modulations of the solar cycle, the volcanic eruptions, or the internal variability of the climate system, the natural internal variability of the climate system. The Unfccc it's the main international treaty, the national and international from the UN, the main international agreement by the countries. There is 197 countries under this agreement, and the Unfccc calls for research, meetings, negotiations, and different agreements, as we will see, in order to allow the ecosystem to naturally recover and to adapt to climate change, and to enable economic development to proceed in a sustainable manner. The Ipcc is or the Intergovernmental Panel on Climate Change, is the United Nations body for assessing the science related to climate change. It was established by the WMO, Water Meteorological Organization, and the United Nations Environmental Programme in order to make science available to governments with all the scientific information in order to develop their policies. And this panel was created in 1988, so before even the agreement, the UNFCCC. So science came first, even before the international agreement on treating and addressing and combating climate change. Ipcc provides the main reports for the governments. They focus on the physical science, the adaptation, the vulnerability, the risks, the mitigation, and all the possible solutions, tackled from scientific, technical, and socio-economic aspects. They issue reports in periods of 5 to 7 years. So every 5 years minimum, up to 7 years, there is only one huge report that is issued in order to inform policymaking. And member countries to UNFCCC as well issue reports, but these reports for the members to show the progress towards achieving these, the goals of the convention. It's important to understand that Ipcc does not produce its own research. They do not do research on their own. What they do, and remember, it's the main source of scientific information for all the climate change global policy, they actually assess the human knowledge, assess the literature, and provide those into reports for policymakers. They also assess if there is any gap in the knowledge. They assess the level of agreement on any phenomena, on any progress, and provide recommendations for policymakers. So every 5 years, there is a report, a huge report, thousands of pages. I have been involved in studying and reviewing among a team of scientists with me in the Ministry of Energy in the Climate Change Department. One report is thousands, could be 3,000 pages. The first report was issued in 1990, so 2 years after the establishment of the Ipcc. And each report has a huge impact, high-level impact on the global policy. The first one, after the findings of the report, the main international treaty on climate change, the UNFCCC, was established. The second report led to Kyoto Protocol, which is the first implementation of the terms in the convention, actual implementations. The third report led to understanding of the impacts and adaptation, and a focus on adaptation. The fourth report led to the 2 degrees limit post-Kyoto Protocol. And the fourth report led to the famous Paris Agreement and the commitment of parties included in order to provide nationally determined contributions toward achieving the goals of the Paris Agreement. And the sixth report, this is the current cycle that we are at, ongoing issuing of the report. Report is too huge that it cannot be published at once. So it is published in 3 parts. The first part is on the physical science. It has been published in July 2021. The second part is on adaptation, and the third part on mitigation, and still ongoing. So we published only, or Ipcc published only 1 part, which is the physical science, and still ongoing. But this will have huge impact on, as an input to global stocktake, which is one of the articles in the Paris Agreement that requires assessment of the global progress towards achieving the goals of the Paris Agreement and the temperature goals. And I did not forget these question marks. I put them intentionally because we don't know what else that this report, until it is published, what could be the next huge, large impact that we'll be seeing on the public and the global policy arena. I have the honor to be one of the members in the governmental teams and representatives that actually reviewed and contributed to the approval of the sixth assessment report, the first report or first part on the physical science. Every report of the Ipcc comes out based on consensus. So all the governments need to agree on what's in the report. And this develops or creates a huge adoption of the findings of each report. Okay, now how scientists, as of yourself, can be involved in the seventh cycle. This is we're approaching the next cycle. We're preparing already for the seventh issuance of the report. So scientists can get definitely involved in various roles and fields, as I mentioned, in the 3 areas. But under each of these areas, there is large space for innovation and contribution. In the physical science, can include water cycle, climate system, atmosphere, cryosphere, oceans, and many other topics. In the adaptation can include biodiversity, settlements, urban planning. It's a wide range of topics in mitigation, emissions, technologies, different sectors, even research within different sectors, transportation, buildings, efficiency, and so on. Researchers can get involved as coordinating lead authors, review editors, contributing authors, or expert reviewers. And these range from experienced researchers with renowned research or young scientists who are willing to support the lead authors. And the first 3 that I mentioned, the coordinating lead authors and the lead authors and the review editors, are actually nominated and proposed by the governmental focal points. So the governments, such as we at the Ministry of Energy, propose and nominate the names of the authors for the next cycle to be contributors to the research. And these lead authors recruit the young researchers and the contributing authors to support them in writing the reports. Now to the next question, which is now how, as an early career or a scientist, I want to study climate change. What are the basic elements of climate change studies or research? Of course, if you have been studying any phenomena, you always need a model and then data. You need a scope similar to climate change. Models are key. Models have really been a valuable tool in order to understand and advance our understanding of climate system. Models are numerical representation of a system using a bunch of equations. In the case of climate change, it is based on well-documented physical processes to simulate the transfer of energy and materials through the climate system. Models should represent all the components of the climate system that experience the change over the decades and centuries. the atmosphere, the ocean, cryosphere, and biosphere. Of course, if you are a scientist and want to study climate change, building a climate model is a very, very complex task. And building a model from the scratch is very difficult and a complex process. It requires identification and quantification of the climate system processes. Requires representing the processes with equations, mathematical equations, setting and the variables, initial states, and representing the change that could happen. Running these models through supercomputers extensively in order to be able to get the results over days. But luckily for us and for all the science happened in the past, since 1988, we do have a large number of climate models ready for scientists to utilize in order to understand behavior of the climate system. And these range from, depending on the number of dimensions that they cover, and the number of components included in the model. So they could range from energy balance models with 0 to 1 dimension, representing and calculating the incoming and outgoing energy of the planet, radiative convective models that represent a temperature profile of the atmosphere, general circulation models, climate models, and Earth system models. These are the most popular today and the most advanced and used in the Ipcc reports as well. Basically, general circulation climate models are 2 or 3D models. They cover the atmosphere, the ocean, and the land, coupling and the interaction between these components. The Earth system models are the most advanced, and they represent, on top of these 3 components, as well the ice, the sea ice. They represent also the human dimension and the human interaction to the climate system. Now we have the climate model, which will help us simulate the climate system. But we need to predict to the future. So we will need scenarios. What could happen in the future? Scenarios, they're actually possible stories of what could happen in the future. How fast the population will grow, how advanced the technology will be, how humans will use the land, the energy use. All these details come into scenarios that become input to the climate models and produce a storyline that can be utilized in order to for decision making. And there are endless number of possible scenarios, of course. However, in order for scientists to be able to understand and to utilize specific directions, these are grouped into illustrative scenarios. And Ipcc have been using different groups of these scenarios, grouping. In 2000, they issued the emission scenarios, and they are found in a report that describe these scenarios. So from the name, they are the expected emissions based on the population growth and all the other socio-economic elements up until the end of the 21st century. In 2013, also, Ipcc issued a new group of illustrative scenarios, which is called representative concentration pathways, which focused again into emissions and what could be the radiative forcing up until 2100. The graph you see here is RCPs, the representative concentration scenarios or pathways, where each one has attached to it a number. And this number is the expected radiative forcing up until 2100 by the end of the century. And this illustration here shows that how between the scenarios, for example, the scenario RCP 2.6 and 8.5. Of course, with the change of the temperature, how would it look like? The precipitation, how would it look like? And the sea level rise, how would it look like? One more is the shared socio-economic pathways. And it's very important to consider that or look at these because this is what is currently been in use. And they are, from the name, include additional socio-economic considerations and factors included to expand into the assumptions for the future, including additional socio-economic, including the different GDPs, the different advancement in technology, education, all kind of socio-economic activities that could happen. Now we come to the scope. We have the model, we have the scenarios. We come to the scope. What is that we should consider? Climate change agreements consider the well-mixed greenhouse gases and specific gases. The most important are the carbon dioxide, methane, and nitrous oxide, and a group of fluorocarbon gases. I picked this number from the latest Ipcc report, which was issued, as I mentioned, just last July, with the level of concentrations of the greenhouse gases in the atmosphere, the current levels, and the distribution among sectors. And you can see that energy sector comes high, but industry and agriculture are pretty close, with 22% and 24%, then transport and building. So research in these areas also considered of high importance, the main sectors considered. And another important concept is the concept of sources and sinks. Sources where any activity or a process that actually emit greenhouse gases, whereas sinks are the reservoirs that absorb these greenhouse gases. We have land and ocean have been taken up near constant proportion, which is globally is 56% per year of the carbon dioxide emissions from the human activities over the past 6 decades. Okay. Now comes, we've seen science and we've seen socioeconomics, but also comes politics and the public and the global policy. Climate change also is a developmental issue because all the socioeconomics, as we've seen, included is they've been vital for each country in order to understand their mitigation options in climate change risks. Politics comes not from recognizing the problem, but comes from how do we deal with this problem at the national, at the international levels. What kind of solutions are prioritized and which economic sectors is being prioritized. This is, of course, resulting from the different perspectives of countries how to deal with the issue. Now, we have seen the problem and we know the building blocks and basics how to deal with it, but how scientists can further contribute to the solution space, or what is basically the solution space. The solution is articulated for the climate change issues in two main areas: mitigation and adaptation. And have been saying these words without explaining exactly what do we mean in this context. So adaptation is the process for adjusting self for the actual or expected climate and the effect of this climate in order to lessen or avoid the harm or exploit probably beneficial opportunities. And this kind of action can be a system, can be a program, can be change in behavior. An example is early warning systems or infrastructure and cities designs, also water management and planning programs and conservation. There is also adaptation measures with mitigation co-benefits. Mitigation is the process where we reduce the emissions or enhance the existing sinks that absorb the greenhouse gases. Example is installment of renewable energy or energy efficiency programs. Adaptation with mitigation co-benefits. An example is tree planting, where you're actually adapting to the environment, but also creating or enhancing the sink's effectiveness. There is a group of technologies which scientists can contribute in order to enhance and to prove some of these, and technologies has been a key to combat climate change. And one of these well-known and proven technologies is the carbon dioxide remover, or CDR, which is capturing carbon directly from the atmosphere and storing this carbon into geological or bio-based or ocean reservoirs. Or it can be also used in industrial processes such as products, food beverages, and low carbon concrete, for example. There's a wide array of technologies within the CDR, as we call them, such as biomass carbon removal and storage, enhanced mineralization, ocean-based CDR, depending on where the carbon is being stored. Also, afforestation and reforestation. Another technology, or it's an example of a CDR, is DAC, direct air capture, which is, again, capturing carbon directly from air and storing it into permanent storage, or utilizing it into different added value products. Currently, there is 19 DAC plants worldwide. The latest one was in September 2021 in Iceland, with a capacity of 4 kiloton CO2 per year. According to the International Energy Agency and their net zero emissions by 2050 scenario, DAC has to scale up to a level of 85 metric tons CO2 per year by 2030. So there's lots of bidding on this technology in order to achieve negative emissions, achieve net zero and negative emissions on the longer term. Carbon capture, utilization, and storage is another proven technology, has been utilized in the oil and gas industry since the 1970s. This is when typically natural gas processing plants would supply CO2 or carbon dioxide to the oil producers for a process called enhanced oil recovery to pressure gas into the well to enhance the recovery. The facilities around the world now have a capacity to capture more than 40 ton CO2 per year and storing 20 metric ton CO2 in deep saline formation. This is from Norway in 1996, a plant that has been utilized and been up until this point has been stored actually 20 metric ton, which is considerable number, given that if you go back and remember the numbers that we have seen in the scope, 60 metric ton CO2 per year is the current emission. National-based solution and ecosystem-based solutions. KAUST has been pioneering in this area. And I have here the picture of Professor Carlos Duarte in his research on coastal wetlands, where mangroves have been utilized, mangrove trees have been utilized with their straw-like roots in order to transport air into the root under the soil. And scientists and students in Red Sea Research Center, they are utilizing this knowledge and building on that in order to understand how mangroves sequester, capture and store CO2 from the atmosphere, and how this would help the ecosystem in general and increase the diversity, the biodiversity, and enhance the coral reefs. And I have a quote here from Professor Duarte. Today, blue carbon strategies of mitigating greenhouse gas emissions through the conservation and restoration of these habitats have been adopted by many nations as key means of meeting their commitments under the Paris Agreement. So he invented this concept of blue carbon in order to support the mitigation strategies of countries. I urge you to check it out if you have not done so. Other approach is comprehensive solutions. And one of these comprehensive solutions is the circular carbon economy, which is a proposal from Saudi Arabia in the G20, and it was endorsed by all the G20 members. And KAUST also been contributing to this strategy and advancing the research and the implementation means of circular carbon economy. Circular carbon economy is an integrated and inclusive approach to transition to a more sustainable and more comprehensive, more resilient economy, where all the energy systems are possible, all the technologies are possible for the government, and in the same time they're able to achieve their commitment toward the climate change convention and the Paris Agreement goals. The circular carbon economy builds on the existing concept of the circularity and circular economy with reusing material and recycling material and reducing the use of unneeded use of material, but also adds to it the concept of remove within carbon processes. So we reduce the carbon emissions in the first place with energy efficiency and other programs, reusing carbon into industry and into value-added products, recycling carbon through storage and reuse, and removing any excess through utilizing the DAX, CDR, or CCUS technologies. So I have three key takeaways that I'd like you to remember after this talk. The first is that science is leading climate change understanding, dialogue, and the international negotiations. So science comes first, and then the policy and the negotiations. Ipcc is currently releasing the 6th assessment report, and scientists and young scientists can get nominated by the government focal points, like the Ministry of Energy in this case, in Saudi Arabia, to author the Ipcc 7th assessment report starting later this year. The third point is that mitigation and adaptation provide solution space, and large this solution space is very large. Currently, it includes a large number of technology options, such as direct air capture, carbon capture, utilization and storage, nature-based solutions, comprehensive solutions, such as the Kingdom of Saudi Arabia circular economy. Thank you very much, and it was a pleasure to be with you. And if you have any questions, I'll be ready for that.
Thank you very much for the talk. It was a pleasure to listen from a different perspective on the whole energy policies. First, I'd like to start with our in-person attendees. If you have any question, please stand up and take the mic, and don't be shy. I think this is a great moment to ask questions, which we cannot find often. In the meantime, I have an online question. What is the biggest challenge in representing the Kingdom of Saudi Arabia in such organizations you mentioned, like Ipcc or Unfccc and other platforms? What do you find it challenging? That's what I understand.
Thank you. Thank you for excellent question. So I come from a place where science and policy interact together a lot. So I don't come from a view of complete political or complete policy side, but rather from a science-based interaction. And here, as the Kingdom of Saudi Arabia, and this is our direction, we embrace science. We understand it. That's why I'm, as a scientist, I come from the scientific background, by the way, and I'm working with the Ministry of Energy in order to interact effectively, understand the scientific aspect of climate change, and have a positive contribution into these platforms, where science has been, as we've seen, the basis of the negotiations. And we make sure that we represent the effort of the kingdom in the most transparent way. We make sure that we do also understand the commitment towards the international agreements and represent the internal direction into the international space and international arenas. I hope this answered to some degree your question.
So I have another online one, or is there any in person? Yeah, I see Iman. Please go ahead.
Thank you so much for an interesting talk. My name is Iman Al-Haji, and I'm a PhD student in materials science and engineering and energy storage. And my question is about science diplomacy. And do you think that scientists have failed to communicate in the past their findings? Or was it like we see kind of a gap between climate actions and the understanding of climate change? Could we blame scientists for that, or should we blame more politicians? I'd like to hear your voice on that.
All right, thank you. Excellent question. You mentioned science diplomacy and how politics would affect science, but we should realize that also the representation of scientists is very important into what is the messages coming out. So the more that scientists at the end are also humans, they have their own beliefs, they come from specific directions, from specific regional areas. And this is one of the areas that we work hard in order to enhance that we have scientists from different regional areas. So we have complete representation of the globe, rather than having some areas where scientists have a higher voice. So when also scientists are diverse, then the science that comes out is more diverse and balanced and has the highest coverage. This is, I hope I answered your question.
Thank you. Thank you.
Okay. Welcome.
Thank you, Man. Actually, I will follow up with a similar question, and I feel it's a good opportunity that our students and online speakers can hear from your experience. Because you, as you said, you have a science and engineering background. How was your transition and experience from being a scientist to actually a policymaker organizations? And I know from some of the conversations with some of the female students here, what do you recommend to the students who wants to get out of their comfort zone as a scientist and be involved in this type of science policy and diplomacy activities or work, let's say?
Thank you very much. Thank you for this question. To be really honest with you, I'm really happy and excited and have been feeling satisfied, I should say, extra satisfied to see that science is also contributing to policy, to be able to contribute my scientific background and not to feel that science is isolated or does not contribute to what's happening in the real world. It's very similar to when you as a scientist have a discovery and you have an invention and you actually make it happen in the real world. And this is make it happen, this is again make it happen in the real world, but under the policy. And being able to represent my country and represent in scientific discussions that also very empowering, showing also women involved in science, women involved in policy, women and as the country we're able to also sit on the one table with all the other governments and exchange information and exchange ideas about how do we solve a problem globally together.
Coming back to the question again, do you mind briefly sharing your story, how you started to be involved in this type of things after being an engineer?
Sure. I actually did my PhD in information technology in George Mason University. So focused on modeling. Modeling, by the way, is a great discipline and area because you can model anything and everything and you can be anywhere afterwards. So I focused on modeling during my PhD. I worked after that in a company, Fortune 500 company, and I had clients in the US, our clients in that company was from, Environmental Protection Agency. So I started to know more about water and environment and these areas. And then it came, I went back to Saudi Arabia, became academics, focused on research again. I did my post. Then I started my postdoc in MIT under the Ibn Haldoon Fellowship program, where I focused on water, modeling water desalination systems, and how do we make this process more efficient and less energy intensive. How do we utilize solar energy in order to produce water? Because this is a main and a huge issue in Saudi Arabia, and I wanted to contribute to solving this problem through my research. So I took that route of looking at all this environmental related issues and trying to find solution. And then I also had, as you mentioned in the introduction, I had lots of activities empowering women in STEM, in research, in energy, in clean energy. And one of these were the Women in Clean Energy initiatives. And I was working a lot with the government, with the Ministry of Energy, to support women in energy. Whenever they have a panel or a contribution, then I'll be ready to help with that. So I became even much closer to that. And attracted to me, I was really attracted to understand more about climate change. And this is where it came. I stepped a little bit outside of my comfort zone and started to look at other issues, but with a higher impact, a high impact as well. And I became, then I got the opportunity to work with the ministry directly as an advisor.
Thank you very much. Impressive. So, and actually, again, following on that, I have, you mentioned that you are supportive of the STEM and women included in the policy making, etc. And I've heard that you were one of the pioneers initiating the Ibk Scholarship. And if I mentioned it correctly, yeah. And today, years after we had a chat, we do actually have a faculty at KAUST, Dana Al-Sulaiman, who was one of the first recipients of the scholarship, went to US and the UK for her studies, and now back as a faculty to KAUST. And how do you feel about it, and about this program you initiated coming to full circle, obviously? And also, are there any similar plans to involve maybe Saudi women scientists to the science diplomacy and policy?
Thank you so much. This is a really dear to my heart program, the Ibn Haldoon Fellowship Program at MIT. It started as a collaboration between King Fahd University, KFUPM, and MIT. Within their collaboration, they had a part of their agreement to support Saudi women. And I used to tell them that this is the highest impact of your program, because the support that you gave to Saudi women actually resulted in leaders in many sectors. Today we see them in Saudi Arabia. The program started in 2012, and I think there's about 40 now graduated from this program, and it's ongoing. Now it's under the support. After KFUPM, Aramco supported that program. After Aramco, KAUST supporting that program. And it's going and open to all the female PhDs to apply and to spend a few years, 1 year to extendable, with pioneering researchers and renowned and top of the world researchers, and being in that environment really empowering, and in addition to the capacity building in research and in science. Also the ability to grow a network within your area of expertise and your research with the top of the world researchers. This is another big advantage of that program.
Thank you. We have an in-person question here.
Hi. Nice to meet you in person. My question is about the evolvement of purpose. So you have spoken about different stages of your career and how you come to this place. And I know as professional women, as professional people, not only women, and as scientists, as engineers, as people who work in such institutions, we might feel at some stages we lose purpose, or we lose what is the thing that really drives me to make an impact. And you mentioned impact a few times. So if you can share with us from a more personal side, when you think that, oh, this is what I'm going to do for the rest of my life, and then maybe you start losing passion, and then something else evolves, and something else evolves. What keeps you going in those transformational stages?
Thank you. So yes, as you mentioned, it's transformational stages, and just realizing that we have stages in our lives. We understand that that purpose that I have right now might get adjusted in a few years later, and it's just totally fine, and it's okay. So the most important thing that I don't step a day in my life without having that clear objective. Knowing that it might change, still okay, but I just need to have that objective, which is, I think, for everyone, this is what drives us to get up in the morning and go, knowing that I have that objective, I have that goal, I want to achieve it by the end of the year, by the end of the 5 years, it doesn't matter. But also, I think I came from academic background, totally academic and researcher, to government. I allowed myself to be flexible and took this step, even though it's not typical. Academics usually stay in their academic career until the end of the path. But for me, I evaluated my progress, and I enjoyed my career. I did a lot. I was provost of a university, Al University. I did my associate professor rank, close for my full professor rank. But still, I should be able to try other things. Who said I cannot? Who said I have to stay? Who says I have to stay in one path until the end? So I can explore other paths, and they could be similarly rewarding. And this is what I'm seeing. It is similarly rewarding as long as I am still within my passion. I'm still a researcher at heart, still within science and scientific environment. I did not let this go because I love it. I took it with me in my new path, a new career path.
So you've mentioned being driven and waking up with a purpose. Can you please share with us what drove you from the start and still drives you?
What drives me? Well, a key thing for me is I have to enjoy what I'm doing every day. If I lost that enjoyment, and I mentioned it to my coworkers, my subordinates, I tell them, you know, the day that I don't feel happy coming to my workplace, I will not come. I will stop going to that. So as long as I'm doing what I am really enjoying, and I wake up in the morning feeling that I'm excited to go and do this thing, this is what drives me to go and do more and help also the team with me.
Thank you.
Thank you very much.
There's one more final question here in person.
Hello, my name is Dr. Ula Al-Hagan. I'm Associate Professor from the Physics Department. It's been really interesting and inspiring to our young scientists, actually. And as you see, most of the audience here are females, and which is very good to see scientists now for the females. I mean, they're understanding their rules, they're understanding the importance of being a scientist, and they're actually more open and more passionate. Before, we're not able to do a lot of things. Now, everything is available to us, and this is very good. My question is maybe more scientific about the climate changing. As you see, or as you say, it requires a lot of modeling, a lot of scientists. It's more complex system. You know, we heard that Nobel Prize in the 2021, there was a groundbreaking for understanding complex system. And the Nobel Prize has been, half giving to Manabi and Klaus Hasselmann for understanding the modeling of the climate changing. My question is, how much contribution of this finding of the complex system to our world? I mean, have you been see the accomplishment of these Nobel Prizes, and have been implemented or making lives easier to understand the complex system of the climate changes? And thank you.
Thank you. Thank you for your question, and thank you for the encouragement of women in science. I'm also an advocate for women in science. For your question about the contribution of complex systems findings, latest findings into climate change research and science, as I mentioned during my talk, the reports comes out every 5 years. So the next report definitely will include findings and information from the current what's happening. So for each report, there is a cut date of the latest information that should be included. And the cut date for this report was, I believe, October 2020, something like that. So, but definitely in the next cycle, we will see the impact of the research that's happening today into the next cycle of reports. Thank you.
Thank you very much, Dr. AlNory, and thanks for the questions. This is the end of the session, and Kaust just has a little trophy for you to give as a present.
Thank you.
Yeah.